Hi ladies, this video is the second video for exam 1 revision, going through the solution. So this video is focusing on the probability questions. So there's two other videos, one for parabolas and one for trigonometry. Okay, so let's get started. So two independent, and that's important, two independent events A and B are such that the probability of A equals 0.3 and the probability of A and B equals 0.18. So we have to find the probability of B. Now, the fact that they're independent events is what is important here. So you're going to get a formula sheet. Okay, so in terms of probability, you're going to get the addition rule, the conditional probability formula, and the independent events formula. So this is what we're going to use now. So the probability of A and B is equal to the probability of A times the probability of B. So let me just write that down. Probability of A and B is equal to the probability of A, times the probability of B. And then we just substitute the values in. So A and B is 0.18. The probability of A is 0.3. And then the probability of B is what we want to work out. Now, we just need to get probability of B on its own. So let's divide both sides by 0.3. Now, you do need to know how to deal with decimals. Okay, so this isn't a difficult one, probability of B. We've got 0.18 divided by 0.3. So how many times basically does 3 go into 18? It's 6. So your answer is going to be 0.6. All right, so I might just put a square around the final answer. Okay, question 7. In a group of 52 students, 27 like Buffy, 17 students like Angel, and 5 students like both. It's quite interesting when I see Buffy and Angel, because I think I was in high school when Buffy the Vampire Slayer came out. So I wonder whether any of you actually know who Buffy and Angel are. All right, so complete the Venn diagram below to represent this information. So we've got 52 students in total. Actually, I might just highlight the important parts. 27 like Buffy, 17 like Angel, and 5 like both. The part of 5 liking both is the important part, okay? So that goes in the middle here. And with Angel, so 17 like Angel, so we've already included 5 of them because 5 of them like both. So that means the other 12 only like Angel. And then with Buffy, 27 like Buffy, but 5 like both, so only 22 just like Buffy. And we've got 52 students in total. So we've got to see how many there are currently. So we've got 12 plus 5 is 17, plus 22 gives us 39. So that means we've got an extra 13 who don't like either. Okay, so let's just double check that I've added that up correctly. So 22 and 13 gives me 35, 40, 52. Beautiful. A student is chosen at random from the group of 52 students. Find the probability that the student does not like either Buffy or Angel. So that's just going to be 13 out of 52. Now, when you're dealing with cards, we always do with 52 cards in a playing deck. So hopefully you notice that that's 1/4. Complete the Carnow table below to represent this information. We did refer to it as a two-way table, but it's just another name for the table. Okay, and I need to be able to see the values. So A and B is 5. And how many liked Angel? It was 17 from memory, is that right? Where did I get 17 from? Oh yeah, that's right. And 27 like Buffy. Okay, Now I've got enough information, so 27. All right. I love two-way tables more than Venn diagrams, but some students like Venn diagrams more. Okay, so 27 plus what gives you 52? So 27 plus 27 is, oh, not 52, sorry. It's 54. 27 plus 25 gives you 52. Okay, so remember your columns and your rows have to add up. So that's going to be 13 there, and then that's going to be 35, and good, that adds up to 52 on the bottom. Okay, so question D, find the probabilities of, so this is not A or B. So basically, this is probably going to help if I highlight it. So I might do it in green. Okay, so we've got the probability of not A is 35. So 35 students don't like A. And the probability of B is 27. Now, just remember that we're basically looking at this row, sorry, this column. Whoops. I'll make that a little bit bigger. And this row. So you can see that 22 has been included twice. That's what the addition rule is. So if I go to my formula page, you can see the addition rule there. The probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So A and B in that case is just whatever you're looking at. So we're looking at not A and B here. So with this, we've got 35, okay, plus 27. And we've got to subtract that 22 because we can't count it twice. So we're going to have 40. Now you could subtract what you don't want. That's another way of doing it. So 35 plus 27 minus 22 gives you 40. So the probability of not A or B is 40 over 52, and we should simplify that. So that's going to be 4, hold on, 20 over 26, 10 over 13. All right, so this time we're looking at conditional probability. So the probability of not B given A. So again, you've got given the conditional probability formula here. Okay, so the probability of A given B equals the probability of A and B all over B. Now, remember your A and B just changed. So this is just your broad formula, and you just apply it to whatever you have to do in your question. So I'm going to write the probability formula down. I probably should have written the addition rule here. So maybe I'll go back and do that. So probability of A, sorry, not A or B equals the probability of not A plus the probability of B minus the probability of A and B. Okay. Should I do all the 52? There we go. All right, so conditional probability. So the probability of not B given A is the probability not B and A over the probability of A. Okay, so you can write the probabilities, but because we're dealing with numbers, I'm going to change it to numbers. I always do that. And I think on the formula sheet, it's written as probabilities, but you can, if we're dealing with numbers here, so in this two-way table, we're dealing with the numbers, not the probabilities, so we can just count the numbers. We don't have to write the actual probabilities. Okay, so let's look for the cell with not B and A. So not B and A is here, which is 12. So it's going to be 12. And not A, sorry, over A is 17. So 12 over 17. Okay, I'm just going to get rid of that so it doesn't stay on my sheet. Okay, question 8. A pond contains 7 goldfish and 8 blackfish. Tully goes fishing for her dinner that night, so she will keep all fish caught. Tully has a good day and catches 3 fish. Complete the tree diagram below by labeling each branch with the correct probability. Okay, so she can get a goldfish or a blackfish. So we're going to have gold, black, gold, black, gold, black, gold, black, gold, black, gold, black, gold, black. Now she's catching 3 fish, or she does catch 3 fish. They're 3 different fish. You can't catch the same fish more than once. So this is without replacement. So when you're doing your probabilities, just make sure you take into consideration if there's a reduction in the number of fish. So just remember there's how many goldfish? 7 goldfish. So 1, 2, 3, 4, 5, 6, 7, and 8 black. 2, 3, 4, 5, 6, 7, 8. So you don't have to write this down, but I just want to show you how you do your probabilities. So we've got 7 goldfish out of a total of 15 fish. So the probability of getting a goldfish is 7 over 15. I feel really weird that she's going to eat a goldfish for dinner. I don't think they mean a little goldfish that you have maybe at home, but yeah, it still doesn't sit well that, this little goldfish is flipping around on a dinner plate. Okay, 7 over 15, 8 over 15. Now, if she catches a goldfish, one of those goldfish is no longer counted. So the number of goldfish is reduced now to 6. Okay, so you can see there, 1, 2, 3, 4, 5, 6. And we've only got 14 fish now, so 6 over 14. But the number of blackfish has stayed at 8, so it's going to be 8 over 14. Just remember on your branches, your probabilities have to add up to 1. So 6 over 14 plus 8 over 14 does give me 14 over 14, so I know I'm good. All right, then I'm just going to do the goldfish. Keep going with the goldfish. So she catches another goldfish. She's now only got 5, and then she's got 13 fish. Okay, so 5 over 13, but she still has her 8 blackfish, so 8 over 13. Okay, so just remember the reduction in your probabilities. All right, I'm going to get rid of this on the side here. I'm not going to do it for every fish because it's just going to take forever otherwise. But let's just quickly fill in all the probabilities. Okay, so moving down here, if a blackfish is gone, we still have the 7, but there's only 14 fish and 7 over 14 black. And then here, we've got 7 gold over 13. And, oops, no. Oh, no, sorry, it's 6. Let's get rid of that. So I knew I had made a mistake because it wasn't adding up. Okay, so 6 out of 13 and then 7 over 13. And then, well, then I know that will have to be over 13. Okay, so we've got now 6 gold and 7. And then at the bottom, we've gone down 1, so 6 over 13. And Sorry, that should be a 7 over 13 there. Okay. So you could simplify these probabilities, girls. It's going to take you a while, so just leave them as whole fractions. That's fine. You don't then have to work out the probabilities for each one. Okay, so just filling in your tree diagram like that is fine. If you do go ahead and do the calculation for each outcome, it's going to take you forever, especially with these fractions. So just leave it like that. And what is that question worth? 3 marks. Yeah, so your 3 marks are probably for each fish caught. Not each fish, but you know, the first branch, lot of branches, second lot of branches, and the third lot of branches. Okay, what is the probability that Tully catches at least one goldfish? So all your outcomes, you can write, remember you follow your branches, so G, 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 so she can have 3 goldfish. She can have 2 goldfish and then 1 blackfish, so G, G, B, G, B, G, G, B, 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 G, G, B. Got my G's and looking like lowercase b's. B, what was I up to? B, G, B, 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 G, and then B, B, B. Now, we should have the same number of outcomes as the last one. So 2, 4, 6, 8, 2, 4, 6, 8. So I didn't miss any. Now, she wants to catch at least 1 goldfish. So basically, we want that outcome, that one, that one, that one, that one. Anywhere we see a G. So we see a G everywhere except for that last one. So you could say, oh, I need to do the probabilities of all these, but that's just silly. So remember, all your probabilities add up to 1. So the easiest way to do this question is do the probability of at least 1 gold is equal to 1 minus the probability of no gold, which is 1 minus the probability of B. Okay, so now all we have to do is just do the probability of BBB. So we follow the branches. So it's going to be 8 over 15, and we multiply them, 7 over 14, and then 6 over 13. Now, when you're multiplying fractions, don't go ahead and multiply all your numerators and then your denominators. You need to do some sort of cancelling first. So I'm going to do it on the side here just to show you. So effectively, all your numerators are multiplied together and all your denominators are multiplied together. So you can actually interchange your numerators and your denominators. So for this one here, I would be looking for common factors. So I would look at the 6 and the 15. Okay, so that can become, so the common factor is 3, so 2 and 5. And you can also do the 7 and the 14 can become a half. And the 8 over the 13 we can't change. So now this is going to be 8 times 1 times 2 over 5 times 2 times 13. And now we can do some more cancelling. So those 2's can go. And now I've got 8 over 5 times 13. So 5 times 10 is 50. 5 times 3 is 15. So it's going to be 8 over 65. So we've got 1 minus 8 over 65, which is going to be, oh gosh, let me just think, 57 over 65. And we can't simplify that any further. All right, is that the last question? No, we've got another one. Okay, so question 9. Is there another one after this? Let me just check. Cool. All right, a box contains 16 marbles numbered 1, 2, 3, all the way to 16. One marble is randomly selected. Let A be the event the marble selected is a prime number greater than 3, and B be the event the marble selected is an odd number. Represent the above scenario in a Venn diagram. Oh God, I can't talk properly. On a Venn diagram. Okay, so let's look at A first. So I'm going to put all the numbers out, and I'll put commas in between. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so the first event I'm going to just underline in pink. Okay, so we want a prime number greater than 3. Okay, so I'm going to go greater than 3. So 4 isn't prime, 5 is, 7 is, 8 isn't, 9 isn't, 10 isn't, 11 is, 13 is, and 14, 15, 16 aren't. So 5, 7, 11, 13. All right, and let's do event B. The marble selected is an odd number, so I'm going to underline that in a different color. Let's do blue. Okay, so an odd number, so 1, 3, 5. I think you all know what odd numbers are. Okay, so I've got 1, 3, 5, 7, 9, 11, 13, 15. Now, we've got to see what numbers are the same. So we've got a 5 and a 5, a 7 and a 7. Oh, they're all, whoops, 13. Okay, so what we've got here, and I might have to draw a bigger circle. Just to fit all those numbers in. Now you could do probabilities or you could do the numbers. I'm going to do the numbers. So this is A and this is B. Now 5, 7, 11 and 13 are common to both. So I'm going to put them in the middle here. 5, 7, 11 and 13. And then for B we've got 1, 3, 5, 7. Oops. They've already been counted. My bad. Let's just rub them out. 1, 3, 9 and 15. And then whatever you're left with goes on the outside. So we're going to have 2, 4, 6, 8, 10, 12, 14 and 16. Okay, so that's what your Venn diagram will look like. All right, so the probability of A, so we've got 16 numbers. 4 of them fit into the probability of A, so it's going to be 4 over 16. Let's just simplify that to a quarter. The probability of B, so we've got 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 16, which is equal to a half. The probability of A and B, so that's the intersection here. So 5, 7, 13 and 11. So that's going to be 4 over 16 again, which is a quarter. The probability of A given B. So again, it's the conditional probability. So the probability of A given B is equal to the probability of A and B over probability of B, which is going to be 4 over 8, which is going to be a half. Are A and B mutually exclusive events? Explain your answer. So if they were mutually exclusive, you wouldn't have an intersection. They wouldn't have anything in common. So no. Because event A and event B have values in common. And you can state what they are if you want. What were they? 5, 7, 11, and 13. All right, there we go. Bye, girls.